All okay? Shall we? So we do first a recap of whatever we had studied. Okay, we do a recap, and our recap says, number one, we had the definition of force. Okay, then we understood what is the SI unit of force. Additionally, from our syllabus, we understood that force is a vector quantity. Then we also understood the characteristics of force. Characteristics of force. ये सब हमने पढ़ा. I hope you have studied and come. You remember the characteristics? Can bring a body from motion to rest, rest to motion, can change speed and direction of a moving body, and can change the shape and size. Force always happens as an outcome of interaction between two bodies. One body will be the applicant, one body will be the recipient. If that interaction is not opposed, the motion state will change. Means either if it was at rest, it will continue in motion. If it was in motion, it may slow down or speed up. It may change direction. If it was at rest, then it may change shape or come in motion. सब कुछ वही characteristics को यहाँ पे डाल देने का, right? All this done, and the SI unit of force is Newton, right? We also understood the CGS unit, which was dyne, D-Y-N-E. Just for हाँ डाइन को डाइन पढ़ते नहीं है ना घर में, मस्त है. कौन यूज नहीं करता है? बिल्कुल यूज होता है. आपके सिलेबस में यूज नहीं होता है, इसका मतलब थोड़ा यूज नहीं होता है. हाँ, उसका यूज in SI unit is less, but that does not mean you should not know about it. So today we will talk a little bit about little bit higher level, but समझने की कोशिश करेंगे. Okay, we'll first study what happens to, what we call resultant force. Okay, or we'll say not resultant is a higher level word which we use in grade 11. अरे चुप रहे रे भाई. We'll talk about net force versus equilibrium. Let's understand this concept first. Net force versus equilibrium. Okay, so we'll understand first what is net force, then we will understand what is equilibrium, and then we'll see 2 or 3 scenarios where some interesting findings will come up. Okay, now see. So suppose you have a body, okay, and forces are acting. Let's say we have a body and forces are acting on the same side. Okay, so this is one more scenario. Say this is one more scenario. So okay, try and understand what we are trying to say out here. Now what we will do, we will bring some forces which will be acting on this body. Okay, let's say more than one force. 4 all scenarios can be. Now there will be more scenarios. We'll debate each and everything. A little bit grade 11, and then we will take you to grade 8 back. Okay, force is a vector. Force is a vector. Every vector can be translated. Do you know what is the meaning of the word translated? Translated means without changing the direction, you can parallelly translate it. What does parallel translation mean? It means something. Then these diagrams will become easier for you to solve. See, suppose you have a force which is shown in this manner. How is the force acting? The force is acting in this direction. This is the vector quantity. Yes, you can parallelly translate it anywhere to your choice. This is my object. Parallel translation means you are allowed to take it anywhere, but don't change the direction or don't rotate it. अब ये फोर्स मान लो इस बॉडी को ऐसे लग रहा है, मतलब आप किस तरफ पुश कर रहे हो? इस तरफ. Isn't it not same as बॉडी को यहां से भी इस तरफ से यहां से खींचो, सेम ही तो इंपैक्ट होगा. इस बॉडी को यहां से हम लगा रहे हैं, इट इज सेम एज यहां से इस बॉडी को खींचो, यहां से खींचो, एक ही बात है. Are you understanding? Force or any vector quantity can be parallelly translated. Only thing you are not allowed is इसको twist नहीं कर सकते हैं, इसको direction you cannot change, you cannot rotate because it's a vector quantity. Its impact is same ना. I pull you by your nose and I push you exactly behind from your head. Isn't the impact going to be the same? The body is going to move in the same direction, right? So this concept we call is every vector can be parallelly. It's a grade 11 concept, parallelly translated. Now we will put that same concept out here. We'll put the same concept out here. Are these two forces in same direction? Figure 1. Are the two forces in the same direction? Yes. Both are pulling rightwards. If you see figure 2, then you can pull out this force and bring it here. It is same as figure 1, just misguiding you and keeping it out here. Are the two forces in same direction? Yes. If you look at this one, then the two forces are in opposite direction. You can even translate this. Look, somebody is trying to pull it this side, somebody is trying to push it that side. These forces are in opposite direction. With this concept, any diagram given to you, will you be first able to understand whether the two forces are in same direction or opposite direction? Chalo ek try karte hain. If you have understood, let's say, what I'm trying to say is, let's say you have a body like this, okay? And let's put some forces into it. Let's put some forces, say, right? Are the forces in same direction? Yes. You can pick up, you try to do one simple thing. Take any one edge and bring all the forces on the same edge. This arrow, this is done simpler to you. This arrow can be brought here or this arrow can be taken here. No issues. In this case, whichever arrow you bring, it's a crisscross mechanism. These forces are not in same direction. These forces are in same direction. So at this level, tell me, do you understand? Can I tick on something that whether forces are in same direction or not? Can you actually analyze that? क्या आपका इतना intelligence आ गया है that you can find both the forces are in same direction, right? Okay. And when you are in grade 8, these forces, whichever we will be talking, would be parallel. They won't try to complex it to you. Parallel means just look at the two forces, they're always parallel. This is also parallel to this. This is also parallel to this. In this case, in mathematics, we call them as anti-parallel or anti-parallel, means same parallel but opposite direction. They are called anti-parallel. Anti-parallels are also parallel, just that their direction is opposite. This is also parallel. What you will not get in grade 8 is something like this. Grade 8 में आपको ऐसे नहीं मिलेंगे. Are these two forces parallel? No. This you will understand in grade 11. ऐसा नहीं आएगा. So by now we know that if a parallel system or an anti-parallel system of forces is given, am I in a position to identify and find out whether they are in same direction or not? Ask yourself. ठीक है? Okay. आगे चले थोड़ा सा. Can I change? Okay. So the given material to us would be, sorry, okay, what will be given to us? We will be given parallel forces. We will be given parallel forces. Now these parallel forces can be in same direction in easy manner, or there will be some sort of, what to say, puzzle. In both cases, if it is a puzzle, you solve the puzzle. Ultimately bring it to easy manner. Got it? Or they can be in opposite direction. Opposite direction. Opposite direction can also be given to in easy manner, or they might be given as a puzzle. If they are given as a puzzle, you make it easy. Your job is to make it easy. Right? After this, what we learn is, if your forces are in same direction, then the net force is the sum of all forces. And here it will be difference of larger force minus smaller force. अच्छा, पहले इसको देखेंगे. If you are getting a system which is acted upon by a lot of parallel forces, your first job is to do what? Your first job is to make it simple. एक तरफ में सारे forces ले आओ, and then see whether the forces are in same direction. Okay, if same direction, bring it to one side. Then how to find out the resultant force? The resultant force is found by adding all the forces. So what I mean to say here is, say suppose, okay, sorry, say suppose I look at this particular diagram. Okay, पहले समझो. Let this be 5 Newton. Let this be 3 Newton. Now what is the total force? 8 Newton. You can replace it with one arrow, and that one arrow will be how much? 8 Newton. Now similarly, if this was say 4 Newton and this is 4 Newton, then what is your resultant force? 8 Newton. Okay. अब इसमें देखो, let's say this is 3 Newton and say this is 2 Newton. It is a 5 Newton force acting which side? So if you bring both the arrows on one side, then it becomes very easy to know the direction. It's very easy. Now it is 8 Newton on left side. Sorry, right side. This is 4 Newton upwards. This is 5 Newton left side. ठीक है? Clear हो गया? Say suppose you encounter such sort of scenario in which say let this be 2 Newton and let this be 1 Newton. Okay? Let this be 2 Newton, let this be 1 Newton. Now what is the net force? Bigger minus 1 Newton. But the 1 Newton mein, who is the bigger one? He is the bigger one. So the direction it will take up, the final direction would be on right side. Is this getting clear? Obviously, if I pull your this here by 1 Newton and this by 2 Newton, so 1 out of 2, 1 will cancel 1. And 1 extra Newton will be left, which will be pulling your ear. We call that as the net force. This 2 Newton is actually what? This 2 Newton is 1 Newton plus 1 Newton. A 1 Newton will cancel a 1 Newton. You're still left with 1 Newton extra working on it. So body will move this side. Clear ho raha hai abhi? So now we say that if your parallel forces, they are in same direction, then it is, if it is in easy manner, it's fine. If it is in a puzzle, solve it. Net force is equal to sum of all forces. Okay. After you find net force, your job also would be to speak a little bit about direction. So the direction is direction of net force. Whichever way the net force is pointing, net force. Did you understand this one? Direction of net force. Means if it was a, see, in these, the problem will not be there. Ultimately, it will move in the direction where all the forces are acting. Only here there will be an issue. Because here somebody is giving money, somebody is taking out money. End of the day, you will be either on a deficit or you will be on a surplus. That will depend upon how much you earned, how much you spent. Which one? Either it will be easy or it will be given as a puzzle. ये तो लिखने के लिए समझाया आपको, puzzle up रहेगा, right? अब जरा देखते हैं one more scenario. Let's see one more scenario. थोड़ा और कॉम्प्लेक्स करते हैं इसको. Let's see this. 5 Newton, 4 Newton. How much is the total push on this side? 9 Newton. And how much is the push from that side? 11 Newton. So ultimately, कौन जीत रहा है? Who is it? 11 Newton is winning by how much? 2 Newton extra. So it's combined diagram. If I try to break this up and make some more combined diagram, so that if they come as competency based question, you should be able to understand. Okay. So you combine these two forces. If I combine these two forces, I get how much? 9 Newton. And the fight is with how much now? 11 Newton. Can I combine it further? Yes, sir. You can combine it further also. How to combine it further? So I can bring the 9 Newton on this side and the 11 Newton is on this side. Now who is bigger? 11 is bigger. 11 minus 9 is 2 Newton. So what is the final impact on the body? The final impact on the body is a force of 2 Newton on this side. Or else, if you also draw this, then also you are absolutely correct that the final impact is 2 Newton on this side. बोलो समझ में आया? Bigger, larger force minus smaller force. अरे इतना याद मत कर, आप इसको समझने की कोशिश करो. ये तो मैंने आपके लिए लिखा, ये आपको बुक में नहीं मिलेगा, इसमें इतना मत जाओ. आपको ये सॉल्व करना आया कि नहीं वो देखिए. Did you understand? See, you all are busy in copying this. You should pay more attention on this. How did I solve this system? How many forces on this side? 5 Newton, 4 Newton. What is the total? 9 Newton. What is the total here? 11 Newton. So 9 and 11, they will actually, you all are 3. Sit in middle. Aram se. Reyansh, come little bit this side. On your left. Push the stool inside. Na? आराम से 3 में, यहाँ पे 4 बैठते हैं grade 10 में. 3 को जगह नहीं हो रहा है. अच्छा, ओके, चलो ये समझ में आया. Have you understood? Anyone has any doubt in this schematic? Yeah, बोलो बेटा.
Both these sides have this lemon.
We will come to that. I have still not taken that. Have you understood this? Which one? Net force is the total force that acts on a body. This is what we said. Net force is ultimately bring the body and bring one force acting on it. That is the net force. So many forces were acting. We simplified. This is the net force. What is the net force on the body? A 2 Newton force acting on the left side or westwards, whatever you want to say. Is this clear now? Now in this system of forces, तुम तो लिखे ही नहीं हो, diagrams नहीं बनाए हो, ना slow हो. So there are some more interesting things. Okay. So we say if equal and opposite parallel forces act on a body. If equal and opposite parallel forces act on a body. This is what Swam you were trying to say. अब करते हैं इसमें equal and opposite parallel forces act on a body. We don't know. Let this be x Newton. Let this also be x Newton. Now see the case. Are they equal? Forces are equal by their magnitude. What is the magnitude here? X Newton. What is the magnitude here? X Newton. And opposite forces. Opposite is given by the arrowhead, the direction. This is x Newton on the east. This is x Newton on the west. Then net force. Now I said that how do you calculate the net force? It is the difference of the larger minus the smaller. अब इसमें larger smaller कोई है क्या भाई? नहीं है. तो x ले लेंगे, x Newton minus x Newton, 0 Newton. That means a big finding. If equal and opposite parallel forces act on a body, then net force on the body is 0. This question may come as assertion reasoning to you. If equal and opposite parallel forces act on a body, the net force is 0. किसी ने 5 रुपया ग्रैंडमा ने दिया, 5 रुपया आपने खर्च कर दिया. What is the net savings?
0.
0. हाँ.
There's the force pulling the body upwards, and then there's force like pushing it from the left to right.
No, that is then in your grade 8 that does not qualify because it's a system of non-parallel forces. In grade 8 we will see parallel forces system only. The forces are acting parallel to you. What you are trying to say is pull my ear by left hand side and push my head. So the two forces, look at the forces. This force is going out this side and this force is coming down. So it's a 90-degree system of forces. They are not parallel. In grade 8 we are supposed to study parallel system of forces. Right? Now in this scenario, two things might happen. This scenario, okay, let's see the scenario more closely now. What is the scenario all about? Two equal and opposite parallel forces. Let's see. Observe, see, these are getting recorded. Observe how the diagrams are made and what I am trying to say. That is more important for you. Now see this scenario. A lot of stories will be there. Now again, this is equal and opposite. Both the diagrams, this is say case A and this is case B. In both the cases, the body is subjected to equal and opposite forces. Do you agree? X Newton. Either dekho to both the X Newtons are on this side. So let's put our first day's learning. A body is at rest. Both forces are on which side? What characteristic will you see? Change in shape and size. Change in shape and size. This also same thing. Both forces are acting, right? Now, in this case, what we are finding that for both the forces, the line of action coincides. Here, the line of action are different. Have you understood what is line of action? Line of action is the action along which the force's impact will be felt. I pull his nose in this direction, then his nose will be pulled in this dotted line which you are unable to see. In childhood, you must have done one very dirty thing. By chewing gums, you must have pulled the chewing gum out. Everyone has done that. Have you seen? So you have not done. That's why I say you all are Gen Z. Examples don't go well with you. Have you ever tried to pull out a chewing gum? So when you try to pull out, or you eat that nonsense thing called cheese. When you eat cheese, have you seen? The cheese pulls out like a thread. You can pull out that, right? So when you pull out a chewing gum, you're exerting a force in the outward direction. Which direction does the thread of the chewing gum form? Along the line of action of the force. So line of action is the line, that imaginary line where the force's impact will be felt by the body. Are you understanding? In this, both the forces, the line of action coincides. Here, the line of action is not coinciding. Do you see? There's a difference. The dotted yellow line is the line of action. So if your forces, so here there's a nice thing. We will say, what is the net force? Sir, the net force here is 0 Newton. What is the net force here? The net force here also is 0 Newton. No questions asked. 0 Newton, 0 Newton. But this body will be in equilibrium. What is equilibrium? Whatever state it is, it will be in that state. It is in rest, it will continue to be in rest. This body will not be in. Did you understand what I tried to say? This will not be in equilibrium. ये घूम जाएगा, rotate हो जाएगा ये body.
That was one.
ओ नहीं, 0 Newton है. ध्यान दो क्लास में. What are you doing? 0. You are not paying attention, Sahaj. If this is 0 Newton, I'm writing 0 Newton. How can you bring O out here? Pay attention in the class. You are fickle minded. इसलिए आपका book गिरता है, pencil गिरता है. यहाँ ध्यान दीजिए. 0 Newton. Yes, it will rotate. You can do it with your pencil box. Give equal and opposite forces in opposite direction with a difference in the line of action. It will rotate. You करके देख लो अपने pencil box को दो finger दो तरफ से देके देखो तो pencil box rotate हो जाएगा आपका. You know what I'm trying to say? Just give 2 fingers like this. It rotates. But put the 2 fingers exactly axially opposite to each other. It is in equilibrium. कुछ नहीं होगा उसको. This is the concept of equilibrium. Though that means one thing we have understood. Again, an assertive reasoning question. If net force acting on a body is 0, can you say that the body is in equilibrium? No. No. Net force acting on a body 0 does not mean body is in equilibrium. It can still move because we still don't have clarity on the line of action of the forces. जब तक आपको कोई line of action नहीं बताएगा या pictorially present नहीं करेगा, आप children, these are important because now you will get questions which will be competency based. 4 figures will be given to you and they will ask you, what is the net force? Is the body in equilibrium? Net force 0 होने के लिए एक ही criteria चाहिए. Sum of all forces should be 0. How the sum? Algebraic sum. If this is a 5 Newton, ये इस तरफ जा रहा है ना, इसको 5 positive ले लो. ये इस तरफ जा रहा है 5 negative. Add 5 positive, 5 negative, 0. 0 means net force is 0. We further have to answer what? Whether the body is in equilibrium. If the figure is given, only then we can say it is in equilibrium or not. if the figure is not given, we cannot speak about its equilibrium. Equilibrium समझ में आया? Equilibrium means end of the day you come back to what you are. In higher grade you will study something more called stable equilibrium, unstable equilibrium. What is a stable equilibrium? कभी कभी एक चेयर को थोड़ा सा इक्विलिब्रियम से हटा के छोड़ दो, कट 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 रुक जाएगा फिर से. That's called a stable equilibrium. Our buildings which we have designed higher level are also vibrating. Every building vibrates. Yes, there is a vibration. Yes, every building, everything in this world is vibrating. This D tower is also vibrating. However, its vibration is within stable equilibrium. You will not feel. If the vibration is more than the stable equilibrium says, कभी washing machine चलाते देखो, गट 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 करता है. The first thing the washing machine needs is proper positioning. If the washing machine is not properly positioned, then it will have unbalanced forces. Once the washing machine will have unbalanced forces, it will vibrate. So every washing machine will have some unbalanced forces. When we do the spinning and the rinsing operation, some washing machines are very quiet, some washing machines make a lot of noise. Means उसका unbalanced forces बहुत ज़्यादा है. उस unbalanced forces अगर इतना ज़्यादा है that is stable equilibrium, then देखना मशीन जहाँ पे चला के आए थे, कपड़ा धोने के बाद मशीन 2 कदम आगे चला गया है. Why? Because so much is the vibration on that machine, and that is not good. Your job is to make the object stable. So even when these Volvo buses, how they are designed, they are turning at a speed of 80-90 के speed में turn करते हैं. Sometimes you will see in race and other things, the bus will go, उड़ गया, 2 wheels उड़ गए, फिर ठक करके गिर जाता है. God save them. So they were still in their range of stable equilibrium. Unstable equilibrium होगा तो क्या हो जाएगा? टॉपल कर जाएगा, टॉपल कर जाएगा. एंड टॉपल का एक ही रूल है, ये सब कैम्ब्रिज में पढ़ाते हैं. अगर आपका सेंट्रल एक्सिस बॉडी से बाहर हो गया, देन यू विल टॉपल. दैट्स द मैक्सिमम यू कैन बेयर. और जैसे सेंट्रल एक्सिस अंदर रहेगा, सो दैट मच वी डोंट नीड. आवर जॉब इज नाउ टेल मी वन क्वेश्चन आंसर. टुडे वी डिस्कस्ड अबाउट multiple parallel forces acting on a body. Have we discussed that? Yes. So now revise yourself. क्या रे स्वयं इतना क्या नींद आ रहा है? ब्रेकफास्ट खाया कि नहीं? तो फिर इतना नींद कैसे? Multiple parallel forces acting on a system can act on the same side, can act on opposite side. If they act on same side or opposite side, the net force is always found by the adding of the forces. Forces on the same side add together, forces on opposite side add in algebraic manner, where there will be a bigger force and a smaller force. The net force is found by the difference. What is the net impact on the body? The net impact on the body is like a single force. Ultimately, your body has to be brought into body and one force. That one force is the net force. Pull me with 2 Newton here, another 3 Newton here, replace these two and just pull me with 5 Newton. That's the same thing. Have you understood? After that, we studied that what happens to net force if the forces acting on a body are equal but opposite in direction. One question, if it is equal and opposite, then the net force, if it is equal and opposite, then the net force is always 0. No question about it. Net force will always be 0. However, we have to take a question on what we call as the equilibrium nature. Whether the body will be at rest or whether the body will lose its rest position. So that we find in what manner? That we find by looking at the line of action. If two opposite forces have the same line of action, body remains at rest. Net force 0. If two opposite forces, equal and opposite, act into different line of action, net force still is 0. But the body will not be in equilibrium में नहीं रहेगा. वो अपना state खो देगा. ये rotate कर जाएगा. Clear? And that is exactly what you do in a steering. In a steering, you are pulling it by an equal force on this side and pushing it by an equal force on this side. Is the steering stationary? No. Rotate कर गया. Rotate कर गया. Look at the handle of your bike. And they are all pivoted at the center. Pivot होगा तो ही rotate होगा. Mechanics is very interesting. Rotation होने के लिए हमें एक pivot चाहिए. You do ballet dance and you do figure skating. You just rotate. What is your pivot? The toe is your pivot. Toe पे पाँव रख के the ballet dancer she just spins herself. A pivot has to be there. Pivot नहीं होगा तो कभी भी rotate नहीं करेगा. The Earth's pivot is its axis. It is rotating on that. The steering's pivot is right the central shaft of the, which is right the central bar which is going inside. The handle, your cycle handle, all has got a nut right at the middle of the handle. That is the one which is the pivot. On that pivot, what you are doing? एक तरफ handle खींच रहे हो. आपको लगता है आप दोनों तरफ खींच रहे हो. आप एक तरफ खींचते हो, एक तरफ पुश करते हो, तभी ना आपका साइकिल टर्न होगा. सोच के देखो. शायद ये सब चीजें हम सोचते नहीं है रोज की जिंदगी में. ठीक है? क्लियर? So can I say that by now you have understood? ध्यान दीजिए क्लास में. You have understood what is parallel forces. Parallel forces can be same direction. Sorry. Parallel forces. See, why I write it in this manner, this is called the mind map way of studying. Even when you are studying, many children start just copying everything. Copy karne se, English you can write your own English. Nobody is going to take any marks away from you if your tense is wrong or grammar is wrong, at least in English. What you should know is how thing is happening, the full mind map. And these are the best way to study. Slowly, as you are growing up, your mugging up capacity will come down. You can't mug up that fast. Child will mug up faster. But you're able to understand will increase much more than a child. Your logical reasoning is increasing now. So they can be in same direction. They can be in opposite direction. Right? In same direction, they can be equal or they can be unequal. Right? If they are equal or unequal, in both the cases, you need to find something which is called net force, and it is just the sum. So in this case, equal means both the forces are like this. Unequal means one is like this, one is like this. Same direction. In both the cases, the net force is the sum. देखो ये एक diagram देखने से आपका पूरा story clear है. Opposite direction. In opposite direction, they can be equal or they can be unequal. Figure draw कर लो. Equal होगा तो कैसा होगा? They will be just like this. Unequal होगा तो कैसा होगा? They will be like this. Here, net force will be equal to 0. Here, net force will be larger minus smaller. That's it. And net direction will be equal to the larger direction. देखो तो भाई समझ में आएगी नहीं. Right? In this case, again, two criteria can come. Same line of action, different line of action. This will be in equilibrium. देखो तुम्हारा चार्ट बन गया. And this will be in not in equilibrium. यहाँ पे rotate हो जाएगा. And this is exactly what you do. Not in equilibrium. See this chart for 1 minute and try to understand whether you have understood this chart. Parallel forces can be in same direction, can be in opposite direction. Check this. Make this diagram. बना इसको के कहानी सुन रहा है क्या? हाँ, good. ये तो बैठ के ना खुद लिखोगे तब ना समझोगे. Very good. Excellent. Equal direction, equal in magnitude, opposite magnitude. और समझ के करो. You should read it and make the chart on your own to check make it. They can give you a lot of pictorial questions based on this. At that time, use your gray matter, which God blesses us with less in quantity. चलें आगे. फिर भी नहीं लिख रहा है, देख स्लो है. मैं पानी भर के पी के आ गया, अब तक नहीं हुआ लिखना. And what is your handwriting? Improve upon it. Keep it a point always to check on your teams once you go back home. There will be stuff which, and every time I can't write, I have done this again. I can write on parents group. आप देखते रहो. That is like the diary of your school. चले? Yeah. Yeah. This one you use. Careful, careful, careful. If you need the light switch is inside. Can we go ahead?
Yes.
Sure. So first section was about force, definition, unit and all. Next was about balanced and unbalanced forces, right? This is balance. So in these cases, if the forces are equal, you can also write a word. Then we call them as equal and opposite forces, means the body does not move. We call it balanced forces. And if they are unequal, then we call it unbalanced forces. Unbalanced forces means there will be one net force. Net force equal to zero means balanced forces. If the net force is equal to zero, then we call that they are balanced forces. However, please understand, balanced forces does not mean that the body will be in equilibrium. And if the net force is not equal to zero, then the system is said to be under unbalanced forces. भाई साहब क्लियर हुआ तो सब कुछ? चलिए अगला सेक्शन में हम देखेंगे टाइप्स ऑफ फोर्सेस. Yes, contact and non-contact forces. So we will see contact forces. Wow.
Physical.
Contact force. Okay. Contact forces we say in which the body is under interaction have a physical contact. अब देखो, bodies under interaction, that means the bodies which are under interaction will give birth to what? They will give birth to force. The bodies under interaction will give birth to force, and that's why it is known as a contact force, because there is a physical contact. Types of these forces are, we say, your muscular force, or the physical force that you apply. You lift, you stretch, right? You push, you pull, right? All these type of forces can happen only if the interaction between the two bodies have a physical contact. This is a body in my hand, the stylus. I can push it upwards, I can pull it downwards, I can twist it, rotate it, stretch it, whatever it is. But I cannot just have this suspended in the air and say, abracadabra, pull it, और ये pull हो जाएगा. ऐसा नहीं हो सकता है, because I am applying muscular force, है ना? Muscular force. So muscular force is an example of contact force in which the two bodies undergoing interaction must be in physical contact. You're able to understand muscular force? इसके आपको direct कोई नहीं पूछेगा define muscular force. आपको scenario दे देगा. A man pushes a box of 50 kg on the floor from one point to another. Display what category of force it is, contact force, and what is the example of the contact force being highlighted here. Then you will say muscular force or physical force, whatever you say, right? There is another contact force which is frictional force, but I will not explain right now. मैं इसको थोड़ी देर में बताऊंगा आपको. Frictional force, because this itself is a whole chapter, but we will understand it in nice manner. Frictional force, just keep it written right now. समझेंगे इसको, आराम से समझेंगे. Fine. अगर कांटेक्ट है तो फिर नॉन कांटेक्ट फोर्सेस भी होते हैं. नॉन कांटेक्ट फोर्स सिंपल.
Sir, is gravity a non-contact?
Yes, all we will see. Bodies under interaction have no physical contact. Okay, let's see these three. Non-contact forces. Bodies under interaction have no physical contact. A piece of magnet which pulls up nails. Do they have physical contact? No. Non-contact forces. A person sitting under a tree gets smashed by a ripe mango, which is actually Newton. A ripe mango which is smashed on his head. Was there any physical contact? No. Once it became once this particular attachment became loose, or the attachment gave off, the mango did not go back to the sky. Neither was the mango held at the space. The mango fell below. Right? Why did it fall below? Because this part on which the person is sitting is known as Mother Earth, and Earth pulls everything towards its center. So this is a case of gravity. We'll discuss, and you must have done this also. Take a piece of scale or comb, and you then rub it on your hair, and then put it on bits of paper. Then the paper tuck, 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 get. So these are three types. So we say magnetic force. Yes, magnetic force is an example of non-contact forces. Gravitational force. Gravitational force, and then comes electrostatic force. So we should also know what each of them are. The force exerted on an object, magnetic object, due to the presence of a magnetic field around it. Only magnetic objects will be attracted. अगर प्लास्टिक रख दोगे वो attract नहीं होगा. Magnetic. Higher classes you will again study magnetic objects are of three types: diamagnetic, ferromagnetic, paramagnetic. उतना नहीं चाहिए. So we write that the force exerted on a magnetic object due to the presence of a magnetic field. There is a magnetic field in and around, and the force exerted on a magnetic. Is there a magnetic field around you? Yes, the earth has a magnetic field around us. That's why when you open the compass, it starts pointing towards the north. जितना भी घुमाओ कंपास को, कंपास अब ठीक फिर नॉर्थ में चला जाता है. क्यों? सम फोर्स मस्ट बी देयर ना. वाटर बॉटल को यहाँ रखने से यही रह जाता है ना. मैग्नेटिक कंपास लेकिन वापस आ जाता है. व्हाई? बिकॉज द मैग्नेटिक कंपास नीडल itself is magnetic and it aligns itself towards the north of the earth. ठीक है? So write down the force exerted on a magnetic substance. Force exerted on a magnetic substance due to the presence of a magnetic field is called magnetic force. Due to the presence of a magnetic field is called a magnetic force. Clear? Now, it's not about only Earth has got gravitational force. Every planet has a gravitational force. They will be either more or less than Earth. So how will we define this? Force exerted on a body due to a gravitational field is called.
Why?
Every body has gravitational force. You also have gravitational force. Every body in this universe pulls every other body. You are also pulling the lizard on the wall. The wall's lizard is also pulling you. However, you don't feel that because your mass is very less as compared. When the masses are much, much high, like so you're comparing between Uranus and so say Mars and Earth, then that gravitational force is felt. If you have a ball, and when we throw a ball, the ball comes down because the Earth rules over it. If the ball was sufficiently heavier and bigger than the Earth would have gone towards the ball. Every body in this universe pulls every other body. You are also pulling someone. Right now you're pulling me, I am pulling you, you're pulling her, she's pulling you. Everything pull is going on. But that pull is negligible because our mass is very, very less. So write down, force exerted on a body due to the presence of a gravitational field. If there is a gravitational field, then you will. That's how satellites are launched. How does a satellite go to moon? How does the satellite go to moon? The satellite will be, first you will have a rocket. It has to escape Earth's gravity. Still it will be around the Earth. Do you know that nice little story? ये देखो, अच्छी चीजें देखते नहीं हो ना तुम लोग. How is this is moon. This is moon. And you are launching some Chandrayaan to the moon. How does the Chandrayaan reach there?
So first the rocket will
Lift it from here, which are called the booster rockets, and they will burn out and fall. And then the Chandrayaan will be still under the Earth's orbit. It will be still under the Earth's orbit. Then one day what will happen? After some time, the solid fuel will start burning. And once the solid fuel burns, it will eject Earth's orbit. It will get out of Earth's, and it will fall into the moon's orbit now. This is called translunar orbit transfer. So from there, and then slowly it will be reduced, and then it is brought here. That's how the scheme is done. So you have to come out of someone's gravity and get into someone else's gravity. Hai Mom and dad playing with the baby. Like that. So the force experienced by an object or force exerted on an object when in the presence of a gravitational field is called gravitational force. And the force exerted between two charged particles, you say. The force exerted between two charged particles is called electrostatic force. Force exerted between the comb is also charged, and so are the pieces of paper. न्यूट्रल नहीं है, सब में चार्ज है. चार्ज तो आपके बॉडी में भी है अभी, बट राइट नाउ द नंबर ऑफ पॉजिटिव्स एंड नंबर ऑफ नेगेटिव्स आर बैलेंसिंग यू. Have you understood? If I come with positively charged near your body now, then what will happen? I will repel all your positives and I will attract all your negatives. In a way, I will make you also charged. I don't know how many of you have felt sometimes when you touch your mother or somebody touch करके मारता है ना हाथ में. That is because of the static charge. Sit and watch TV, a large screen TV for some time very close. You will develop static charge on your body. After that, somebody says, "ये चाबी रखो ना," touch करके मारेगा आपको. स्टील की थाली लेने. Plus, if you are wearing dresses which has got lot of sequin, synthetic, not cotton. Girls में ज्यादा होता है जहाँ sequin work रहता है ना, thread. उसको जैसे ही आप ड्रेस को वेयर करने जाएंगे ना, then immediately you will find the body hair also rising up. You'll feel that. Or if you take rayon blankets and all, then you can feel. टक करके मारे. So here we say the force exerted between two charged bodies is called electrostatic force. So gravitational force is any body which has a mass and a gravitational field. Magnetic force is any magnetic material and the magnetic field. Electrostatic force is two charged body or single charged body in an electrostatic field will also feel that. There is a catch here. While you can write that, while gravitational force is always attractive, magnetic and electrostatic force can be repulsive also. Why? Bring two non. Yes, two positive charges will repel. Same poles repel. Unlike poles attract. Simple. So write that. That is very important. If they tell you what is the difference in non-contact, among non-contact forces, there is a thin line difference. Gravitational force is always attractive. Gravitational force is never repulsive. However, magnetic and electrostatic force can be attractive, can be repulsive based on the nature of charges and magnetic poles of the body. Like poles attract, unlike poles attract, like poles repel. Similarly, you should write unlike charges attract, like charges repel. बहुत कुछ बोल रहा हूं, लेकिन आज के क्लास में बहुत ज्ञान गया है. Easy to learn and easy to forget कैटेगरी है ये. क्या क्या लिखना है समझ में आया? What all are going to write? The first point you will write is, while this force is always attractive, these two forces can be attractive as well as repulsive. उसको ना अर्नब कहते हैं चार्जिंग बाय इंडक्शन. जैसे ही एक चार्ज बॉडी आपके पास ले आएगा ना, आपके साथ कांटेक्ट करने की जरूरत नहीं है, आप वैसे ही चार्ज हो जाओगे. You are neutral now. You have 5 positive, 5 negative. And I come now with 10 positive charge. तो सबसे पहले आपके जो 5 positives है ना, उसको उस साइड धकेल दूंगा. और आपके 5 negatives मेरे साइड आ जाएंगे. आएंगे ना? I have not still touched you. So are you not charged now? Yes, you are charged. That is called charging by induction. कभी कभी हम चार्ज बॉडी सर के पास ले आओ, वो वाला क्लॉथ बहुत सारा रहा, then your hair will slowly rise up. Charging by induction. That's why we say when a new friend joins your school, we say उसका induction करवाओ. How will we do his induction? The new friend will ask you, where is the washroom, where is the common room, where is the sports room. So we will assign an existing child of that school as a buddy with that new student for 6 days. And that program is known as induction program. Within that 6 days, that boy will learn everything. Was any book given to him? No. That is called induction. आप धुरंधर मूवी देखते हैं, उसके बाद आप भी थोड़ी देर बाद बाथरूम में नहाते वक्त गहरा हुआ गाते हैं. क्या आपको किसी ने सिखाया वो गाना? नहीं. That song went into your head by induction. देखते 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 देखते. और फिर ज्यादा डोरेमोन देखोगे तो मैं किसी का सपना हूं, आज बन गया हूं सच, तो आप भी गा लेंगे हेलीकॉप्टर. ठीक है? We call that as induction. Therefore, friends are very dangerous. Inductive effect can be good and inductive effect can be bad. पहले आप अच्छी बातें बोलते थे, गंदे दोस्त से मिक्सअप हुआ, 3 गालियां सीख ली आपने, आप भी बोलना शुरू कर दिए. Did you read a book on abusive words? No. How did you learn them? Induction. Induction is very dangerous. In induction, we can induce charge on a body, not by any physical contact. So ये clear हुआ? What are contact forces? Contact forces are muscular forces and frictional force. Okay, and non-contact forces are magnetic, gravitational, and this. The thin line difference is, while gravitational is always attractive, magnetic forces are attractive and repulsive. Same is electrons. And what is the thin line? If the poles are unlike in nature, there will be attraction. A north pole attracts a south pole, and a south pole attracts a north pole. North will repel, south will repel. Similarly, positive negative will attract, negative positive will attract, negative repulsion, positive repulsion.
Sir, but how?
This is
How do we know that?
that is a nice question. That which is a positive and which is negative, arbitrarily assigned. That when we study the chapter of electricity, keep your question parked for that. How do we know that something is positive or negative? खोपड़े में तो लिखा नहीं रहता है ना, I am positively charged. So that in the chapter of electricity. Now listen, children. Whether you're in old course or whether you're in new course, the portion of force is over at this stage. Okay, the chapter may be force and pressure to somebody, so we will learn pressure separately. Somebody in the new course have got this friction part also associated with this chapter, but in the old course friction is a chapter. So in our next content, I will again upload one worksheet on force. Our next science study. वो कुछ नहीं हो रहा. Once we actually complete our this chapter is not yet over. My next part of this chapter will be covering frictional force. Now the old course students, for you this will be elaborate. New students do not have friction force as that elaborate, but you will still learn the elaborate along with us. So this will complete the friction force part. So how to absorb this? This is a contact force. सिर्फ इतना ही लिख देना that friction force is a contact force. Ends it for forces chapter. But from friction chapter, we should know it more in detail. So the takeaway is friction force as a unit we are closing. Now it is your job to make your notes on force. If you encounter this, park it. Next class I will teach this. Next means 1 minute, after the next maths class. Then we will close force. We will no more study this. We'll pick up a chemistry chapter. Have you understood? तो इसको हम डिटेल में पढ़ेंगे, सब पढ़ेंगे. स्लाइडिंग फ्रिक्शन, रोलिंग फ्रिक्शन, जो कि नए सिलेबस में हो भी सकता है, नहीं भी सकता, पुराने में तो है. सब कुछ ड्रैग वैग सब पढ़ेंगे. इसको डिटेल में पढ़ेंगे. बड़ा इंटरेस्टिंग टॉपिक है. आप अब तक के चीजों के नोट्स बनाएंगे और अब तक मैंने जो पढ़ाया उसके ऊपर फिर आपको एक वर्कशीट पेश किया जाएगा. राइट? And I will also, all of you have by now must have got your textbooks also. So open your textbooks, prepare lovely notes out of this so that when you study, these notes help you. Yeah, your questions.
That's what the homework is and not in the worksheet.
Homework is, now you should have your, this chapter is over. Anytime you want to read this chapter, there are two options. Either your textbook or your self-prepared beautiful notes, whichever. I would always believe by my self-prepared notes. And I'll one day bring my notes also for you. I'll show you how I prepare and how I study. Hai mere. And the homework, you'll get a worksheet. How to know? I'm not going to update. You are going to see Teams. आप अपना Teams check करते रहिए, आपको आ जाएगा. By tonight, I will try to upload it. Yeah. Yeah, same. If everything is not submission, I won't say this won't be a submission paper. You can do it at your end. Finish it. It will come as a worksheet. You can do it at your worksheet. Maths, I will call out for submission. Every time I will not call out for submission. This won't be submission, but that does not mean that you have not done. So how will you submit it? Photo maar ke dal dena. Kisme? Teams mein. You know how to put a photo on Teams? Bas. If you are not able to put a photo on Teams, take your mama or papa's phone and put a photo. Bas. आपको आना चाहिए. This will not be a physical submission. I won't ask you a physical submission of this. It will be written along with the worksheet. Just upload a picture.